As n approaches infinity of 1 over n cubed, what is your summation formula for I squared?
N plus 1, 2n plus 1 over 6.
It was over 6.
Yes.
Then minus, here we have this constant 2 times that summation formula. What is the summation formula for I?
N 2n squared plus 1
Over 2. And you could have FOILed that out already or distributed, Jordan, that's fine. And then at the end, it'll be plus 1 times, what is that summation formula for a constant?
The constant.
The constant times n. Okay, so we need to be able to FOIL this out. Yes, sir, you have a question?
Me?
Yeah?
Oh, no.
Okay, question. So
I
if
was-
we FOIL this out, don't we get 2n cubed plus 3n squared plus n? Has anybody done that work?
Yeah.
Repeatedly, right?
Yeah.
So this is definitely what you get.
Yeah.
Here we have, could I just go ahead and cancel those 2's?
Please.
All right, so we'll cancel those 2's. That'll make that easier about distributing. Okay, so at this point, I want to distribute this 1 over n cubed to each of these 3 terms. So I'm looking at this as 3 separate terms. This is 2 separate terms. So we have the limit as n approaches infinity of 2n cubed over 6n cubed. Then plus 3n squared over 6n cubed plus n over 6n cubed. Now be careful here, make sure you are distributing this negative. So that would be subtract n squared over n cubed plus n over n cubed plus, oh, that's a minus, plus n over n cubed.
Yes.
Okay, and so then these will reduce out. And now what is the limit of this constant?
1/3.
1/3. What does this limit go to as n approaches infinity?
0.
0, because don't I have infinity in the denominator?
Yes.
What will this one go to?
Infinity.
Infinity in the denominator, which goes to 0. This one? 0. This one? 0. This one?
0.
So is the answer 1/3?
Yes.
Okay. Great.
I'm gonna go watch
So
this
then let's
video.
look at number 32. Can somebody read number 32, please? I have the limit and the summation already written down. If you can just give me what we're taking the summation of.
1 plus 2i. Yeah, 1 plus 2i over n. Just the 2i's over n.
That's some parentheses.
And then that whole thing is squared.
And is there anything out front, like 1 over n squared? Or anything
2
like
over n. 2 over n.
It's
Find it in
behind
parentheses.
that? Behind it? Great, like this, 2 over n.
Yes.
Okay, all right, so then we need to FOIL this expression here. You don't need me to show you how to do that, correct?
Correct.
You've got that part?
Yeah, we're good, sure.
Okay. So this would end up being 1 plus 4i over n plus 4i squared over n squared times 2 over n. And then I can take this constant of 2 over n out front of the summation. And then I need to use my summation formulas. Please be sure that if you have a problem like this on the AP exam, that you don't leave off any of these details. And we get in a hurry and we start leaving off what we're taking the limit of and what our indexes of summation, indices of summation are, so be sure that you include all of that. Now what happens, yes?
Would it be easier to distribute that 2n to 1 plus 4i over n and all that first?
You certainly can. It does not make a difference whether you distribute first or distribute after we use our formulas. Do whichever way works better for you. So it's fine either way. Would you like for me to go ahead and distribute it?
Yes.
To do it that way?
Yes.
Okay, all right. So then we'll go ahead and distribute the 2n first. So then I have 2 over n plus 8i over n squared plus 8i squared over n cubed.
Yes.
Okay. And then we're still looking at those n's in the denominator as being constants. So when you apply your summation formula, you're gonna do the summation formula and just include that. So now we have the limit as n approaches infinity. So the summation formula for 2 over n would be 2n over n,
Mhm.
right? Because isn't that a constant?
Mhm.
So that's just the summation of that, would be that constant times n, plus, now here I'm gonna have 8 over n squared times our formula for I,
N.
good, and then plus 8 over n cubed times,
N.
good. Okay, so we know these by heart by now, because we've used it so many times in class yesterday. This turns into n squared plus n. This turns into 2n cubed plus 3n squared plus n. Alright, so I really have the limit as n approaches infinity of 2. Now I want to distribute this and to separate these into individual terms. So that would be plus, get 8n squared over 2n squared, plus 8n over 2n squared, plus 16n cubed over 6n cubed, plus 24n squared over 6n cubed, plus 8n over 6n cubed.
Mhm.
And so then some of these terms will cancel out and leave us with constant values. Now as I go through and take the limit of each individual parts, the limit of a constant is the constant. 8 over 2 is just another constant. This limit, since there's more n's in the denominator, would go to 0. Plus 8/3 plus 0 plus 0. We do 26/3,
Yep.
and that is the correct answer?
Mm-hmm.
Okay.
Well, my face is numb, so. I went to the dentist,
Oh,
so that's like, there's nothing there. It's just like da-da-da-da-da-da. Like, it's annoying.
all right, let's look at 33. Are you good? Anybody need a minute? Yes?
The more working stuff, what's that exam? And like, we have n times n plus 1 and the left 1, and I'm like, if we wanted to rewrite it so we can see it better, like to distribute, would we need to rewrite the limit and everything and include it in the whole problem?
No, you could just do some scratch work on the side and be like, this simplifies to be this. So you can definitely do simplification work on the side and then come back and put it into your
I
limit.
ended up needing to like rewrite the whole thing and then switch it out.
You can do that work in the margin somewhere and then come back and put it in here. Okay, can I get somebody to help me out with number 33, please?
1 plus I over n times 2 over n.
No cubes, no. Okay, so would you just go ahead and distribute that 2 over n and then use your summation formulas?
Yep.
So I have the limit of the summation of 2 over n plus 2i over n squared. So when you sum up a constant, 2n over n, plus, and then 2 over n squared times, doesn't this turn into n squared plus n over 2?
Mhm.
Which would be the limit of 2 plus 2n squared over 2n squared plus 2n over 2n squared,
Mhm.
which would simply be 2 plus 1 plus 0.
Yep.
So does 34 have a cube in it? Because y'all really need to see that.
It
Okay.
does.
Yes. All right, so help me out then with 34.
It's the same as 32, but with a cube instead of a square.
Same as what?
Same as 32, but it has a cube instead of what a square was.
Okay,
I can still read it to you.
I got it, thank you.
She's got it, Lucas.
plus two I over n cubed times two over n?
Yes.
Okay, so I think, the issue came in where you had to cube this binomial. Did anybody write it down 3 times and multiply it out repeatedly?
No.
You should have just took it like what you did from 32 and then multiplied that by the third one plus.
Couldn't you do the triangle thing?
Yes. Do y'all know Pascal's triangle?
She did not teach it, she simply showed us. Because she expected us to already know it.
Wasn't it like you go down to the line and you add across and then
Oh,
you?
it's
Yeah.
I'll remind you. I'll show you Pascal's triangle again.
I just got lost in all the.
Okay, so if you don't wanna try to learn Pascal's triangle to use it, then multiply this out 3 times. When you multiply these two factors together, we got 1 plus 4i over n plus 4i squared over n squared. Then you have to multiply it out a 3rd time. So when I multiply this by 1, because I'm gonna distribute the 1 to all 3 of these terms, we get this. And then when I multiply each of these terms by 2i over n, we get another 2i over n, an 8i squared over n squared, and an 8i cubed over n cubed. And now you would just combine any of these like terms. So 1 plus 6i over n,
12i squared over n squared and 8i cubed over n cubed.
Then you just use each formula.
and then you'll go back and use your summation formula. But I think y'all wanted to go ahead and distribute the 2 over n, I believe,
Yeah.
is what y'all wanted to go ahead and do. Do you want me to show you Pascal's triangle, or are you confident in this and you're gonna use this method?
Pascal's triangle.
Okay, all right,
I'll
so,
use that still.
before I complete this problem, let me remind you about Pascal's triangle. This is our pattern for Pascal's triangle. So you have a triangle they have ones here and ones here. To get these numbers in the middle, you're gonna add the row above you together. So 1 plus 1 gives us 2. 1 plus 2 gives us 3 here, and 2 plus 1 gives us a 3 there. Our next row, if it asked you to raise something to the 4th power, would be 1, 4, 6, 4, and 1. But this problem asked us to cube our binomial, so we're using this row. These are gonna be the leading coefficients, so I would have a 1, 3, 3, and a 1. Then you're gonna go back with your binomial, 1 plus 2i, use your first term, which was 1, and it will get cubed here. Then it gets squared here, to the power of 1 here, and to the power of 0 there. And then doesn't 2i over n get cubed at the very back term? So this would have been 2i over n cubed. Then here we would have had 2i over n squared, 2i over n to the first, and 2i over n to the 0. So then you can go through and simplify each of these terms, and it should give us this exact same polynomial. So this just turns into 1, and you would separate these with addition signs. 3 times 1 squared times 2i over n gives us 6i over n. 3 times 1 times 2i squared over n, 2i over n squared would give us 12
12i squared over
I squared over n squared, and then at the end, 8i cubed over n cubed. Same answers we got before? Two completely different methods we will use, find a way that works and use it. So now I'm gonna take the limit of the summation of, I'm gonna go ahead and distribute that 2 over n to each one of these terms. So that'll be 2 over n